Hi students, and welcome to the Magic Square Peter Maxwell Davies online video tutorials. I'm Alex DeLittle and I've already taken you for the Messiaen and Canon lectures this semester. This is my third and final lecture with you. So Peter Maxwell Davies is a well-known composer, and he used magic squares as a compositional technique in a number of his pieces. He uses them to produce material that he can sculpt and craft into musical substance. In this lecture, the lecture is split into two videos. In the first video, we're going to look at magic squares as a means for generating compositional material. I'm going to give you some context about the piece Ave Maris Stella. I'm going to explain to you what a magic square is, and explain to you how Peter Maxwell Davies' magic square works. I'm going to tell you about magic squares as a pre-compositional process. How are they used for the generation of musical material, or rather, how does Maxwell Davies use it for the generation of musical material? Finally, I'm going to explain to you how you can make your own magic square. Whilst we're teaching you about how Maxwell Davies uses magic squares as a pre-compositional process in Ave Maris Stella, alongside it's my aim to teach it to you with a view for you to use this process yourself. In video number 2, I'm going to show how Maxwell Davies uses the magic square to create the musical fabric of Ave Maris Stella. How does he read the magic square, and where on the square are the parts derived from? So I'm going to explain the relationship between the broad structure of the piece and the magic square. I'm also going to explain how the magic square manifests as different parts in the first movement of the piece. Welcome to video 1. We're going to look at magic squares as a means for generating compositional material. So first, a bit of context about the piece Ave Maris Stella. This is one of Peter Maxwell Davies' most well-known pieces, and the entire piece is based more or less strictly around readings of a single magic square. The piece is regarded as one of Maxwell Davies' finest works. It was written in 1975, which was 5 years after Maxwell Davies moved to Orkney. Orkney is an island off the north coast of Scotland. It's an incredibly remote place. I'd recommend a Google Images search, just to give you an idea of what the environment that he composed this piece in looked like. The piece overall has a tightly wrought structure, and there's focus on the music as real chamber music, so there's exploration of the roles of different instruments within the context of the ensemble. You'll see as you go through the different movements of the piece that the instruments all have their chance to speak. The piece is structured as over 9 movements as a long sustained musical argument rather than fragmentary flashes. So it's not just about the single movements, but rather the arc of the whole work. The piece is allegedly based on Plainsong, which praises Mary as a star of the sea, the Ave Maris Stella Plainsong, and the piece is named after this piece of Plainsong. So here's a quote from Peter Maxwell Davies' website. The well-known Ave Maris Stella Plainsong forms the backbone of the music, familiar in settings by Dunstable and Monteverdi, projected through the magic square of the moon. Although magic squares are generally seen as permutations of numbers, this is no more true than with Bell permutations, which are memorable by their patterns of courses rather than by chains of numbers. I conceive magic squares originally as dance patterns, whose steps pass through mazes, and consequently as note patterns, memorable without reference to numbers. So now I'd like you to take the score that was given out in Scott's lecture and listen to the first movement. I'd also like you to have a listen to the other movements of the piece. Maybe don't pay so much attention to them, but I'd like you to listen to the first movement and go through it with the score in detail. Feel free to pause this video now and do that. The link to the recording is on the Spotify playlist that Scott sent out with the email about these video lectures. Okay, so now you should have listened to the piece and studied the score of the first movement. I'm going to explain to you a bit about how magic squares work. So magic squares are a mathematical formation that has existed since prehistory. By formation I mean mode of numerical patterning. A magic square is a distribution of numbers in a square shape, kind of like a Sudoku. And the square, also similarly to Sudoku, adds up to the same on every row, column and diagonal. This even number patterning across rows, columns and diagonals is created from a distinct style of numerical patterning. Squares can be different sizes. We call sizes in the context of magic squares order. So order 4 would mean a 4 by 4 square, order 7 would mean a 7 by 7 square. Maxwell Davies, as I mentioned before, uses magic squares as a pre-compositional technique to derive material. In the previous quote I read you, we know that he projects this plainsong into this magic square of the moon. This is a 9 by 9 magic square, and almost imagines dancing around the square to create bits of musical material. We're going to look at that in a bit more depth in a second. The numerical patterns of magic squares in the context of Maxwell Davies give rise to rhythmic patterns. So numbers in this case stand for rhythms. In the numbers of the square we have pitch values assigned to those as well. So the square can be read both in terms of rhythm and in terms of pitch. And the square can be read or danced across, as Maxwell Davies mentions, in different ways to create distinct pieces of material. So let's have a look at some general examples of magic squares. Oh, sorry, of course this material is then arranged into a piece of music. So these are Agrippa's planetary squares, which date back to 1531. And you can see these are the squares of different orders which are named after the planets. So we have Saturn, Jupiter, Mars, the Sun, and so on. And we have the square of order 4. This is a square of order 3, 4, 5, 6, 7, 8, and 9. And this T is the constant of the square. The constant is the value that the rows, the columns and the diagonals all add up to. So in this case it's 15. So 9 plus 4 plus 2 equals 15. 8 plus 1 plus 6 equals 15. And so on. Feel free to pause this slide and study these squares in more depth. I won't dwell on them long in terms of explaining them, but these are some examples of traditional magic squares. Now, what's different about Maxwell Davies' Ave Maristella square? Well, let's have a look at this in more detail. So this is the square that Maxwell Davies uses in the piece Ave Maristella. So this is slightly different from a traditional magic square. As we can see here, we have the magic square of the moon, which is a 9 by 9 square, but we have one of each number. So the numbers ascend. I'm not exactly sure what the highest number here is, but we have one. We have each number is unique basically. Whereas Maxwell Davies uses this magic square of the moon, the 9 by 9 size, an order 9 square, but he repeats the numbers 1 to 9 only to form a numerical pattern. So the reason that he does that is the reason that the numbers don't continually ascend like Agrippa's magic square of the moon is that 1 to 9 are eventually assigned to rhythm. and numerical values above a certain number aren't useful for the representation of rhythm. So if I took the number 36, for example, and say 36 related to a quaver, so that would be a note with 36 quavers, that would be a sort of unreasonably long rhythmic value to use compositionally. So that's my theory for why Maxwell Davies keeps the square, the maximum numerical value in the square at 9. So here we can see we have the numbers 1 to 9 in each row and column. So we can trace that 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are repeated in a different order each time. If we take the first row here at the top, we can see that Maxwell Davies adds 5 each time to distribute the numbers evenly across the top of the square. So we have 1 plus 5 equals 6. 6 plus 5 equals, well, it doesn't equal 2, does it? It equals 11. But whenever the addition of 5 results in a duration more than 9, Maxwell Davies subtracts 9 from it. Otherwise, the durations would get longer and longer. So 6 plus 5 equals 11. But if we count up to 9, 6, 7, 8, 9, and then we count back from 0, 1, 2, then we have 2. Plus 5 is 7. Again, 7 plus 5, 8, 9, 1, 2, 3. 3 plus 5, 8. 8, 9, 1, 2, 3, 4. Plus 5 is 9. Plus 5, we go back to 0, of course, is 5. So we have this even distribution of numbers using this modulation of 5 each time. Our constant for this magic square is 45. The numbers 1 to 9 all add up to 45. So we have this constant of 45 across the rows, across the columns, and across the two main diagonals, top left to bottom right, top right to bottom left. So there's a specific way that Maxwell Davies distributes the numbers in the square to achieve a certain mode of numerical patterning, and this is what I'm going to tell you about now. So you can see that if we take the top left to bottom right, we have this rather lovely ascending 1, 2, 3, 4, 5, 6, 7, 8, 9. And we also have in these diagonals other ascending patterns, 6, 7, 8, 9, 1, 2, 3, 4, 7, 8, 9, 1, 2, 3. And in this diagonal plane, bottom left to top right or vice versa, we have constant numerical values, so rows of 6s, 2s, 7s, 3s, 8s, 4s, 9s, 5s, 1s, 6s, and so on. Well, how does he achieve this patterning? So we have our, always starting on this top row, we have our numbers distributed as I've just mentioned. What he does is he methodically transposes this row down, but as he transposes it, he shifts it each time. He shifts it 1 to the left. So if you follow my mouse, here we have this row, you can see that the 6 moves to here, and the 1 goes to the end. You can see the 2 moves to here, the 7 moves to here, the 3 moves to here, the 8 moves to here, the 4 moves to here, the 9 moves to here, the 5 moves to here. If we take the next row, it's the same process. So the 2 moves to the beginning, and the 6 moves to the end. In this row, the 7 moves to the beginning, and the 2 moves to the end. And as we have 9 by 9, this row gets transposed 9 times, at which point we have all the possible transposition combinations. And this constant diagonal process is what gives us this lovely patterning. So we have the option when reading this square, if we imagine that these are eventually going to be rhythmic values, of selecting certain ascending or descending or constant patterns or seemingly more randomized patterns. So you can see already that there are many kind of emergent compositional possibilities with the magic square. So that's how the magic square works. As I said, the numerical values are eventually in Ave Maristella assigned to durations. and the numbers could mean a variety of different durations. So 1 could be equal to a number of different rhythmic values. And Maxwell Davies makes use of this. The number 1 isn't always a quaver or always a crotchet. The number 1 has different significances depending where he is in the piece and how he's reading the square. So it could be, for example, a minim, it could be a semi-breve, it could be a dotted quaver or a dotted crotchet. Right, this is the important part. So we've had a look at the numerical values of Maxwell Davies magic square. I'm now going to just run you through, from my explanation it should be already relatively clear how you might make your own magic square, but I'm going to run through this again. The first thing is you have to decide the size. You should have been given in Scott's lecture an A3 handout with some templates for different magic squares of different orders, and you can fill in as many or as few of these as you like, but they give you the options for different sizes. And the size of the square is the order of the square determines your highest number. So if I had a square of order 3, I would only use the numbers 1, 2, and 3. If I had a square of order 9, as we have had with Maxwell Davies, we use the numbers 1 to 9. If I have a square of order 11, we use the numbers 1 to 11. These numbers, the way that I would always start to make a magic square is I would place the numbers across the top of the square. And this order can be determined by you to a large extent. As you can see, Maxwell Davies distributed his numbers evenly, modulating by 5. You could modulate with a different number. You could modulate by 2 each time. You could modulate by 7 each time. This is completely arbitrary. You could try putting the numbers on randomly. Then what you do is you transpose your number row down, displacing it to the left or right by 1 digit each time. So in exactly the same way as we saw with Maxwell Davies square in a couple of slides ago, you would repeat this process with your own square to distribute your row of numbers all the way across the square. In order to check your square, to see if you've got a correct magic square, you have to do 2 things. The first thing is to check your constant. So you want to check all of your rows and columns and your main 2 diagonals add up to the same number. Secondly, can you see patterns like those in Peter Maxwell Davies square? If you have both of these things, you have created a successful magic square. So, what are the pre-compositional decisions in the numerical creating of a magic square? Well, it's one possibility is what order do you put your numbers in? If you're going to be reading the rhythms of this square at a later date, can you distribute your numbers to create a certain pattern that is desirable compositionally? Is that to do with how you modulate the numbers? Is that to do with just putting them in at random and seeing what comes out? These are all questions that you have to ask yourself when you're making the square. Secondly, are you distributing your numbers to the left or the right, and how will this affect your patterning? Okay, so we've looked at the numerical values of Maxwell Davies square, and now we're going to look at the way that he assigns pitch material to the square. Okay, so he starts with this Ave Maris Stella Plainsong, which is it's unclear exactly how and where that comes from. The Griffiths reading that was handed out to you in Scott's lecture has some guesses at how this might be, but no one's exactly sure where the original piece of Plainsong is. If we imagine it's at the top, then as Plainsong is generally fairly tonally or at least modally rooted, we could imagine that Maxwell Davies has probably distressed it somewhat by adding accidentals. So the length of the plain song is exactly the same as the number of squares, so it's 9 notes long. Wherever it is in the square, it's 9 notes long. So you'll have to choose a piece of pitch material that is the same length as the order of your square. So each row, like with the numbers, is a transposition or a displacing of the previous one. Maxwell Davies shifts the pitches as well as transposing them. So I'll just explain that briefly to you. The second row is essentially the first row up a fifth and shifted. So I'll show you how the shifting works. If you follow my mouse again, the last pitch on this row here, this D, is shifted diagonally this way. So it's shifted and wrapped around and it becomes this A. And it's shifted up a fifth. Okay, so we have D, F, A. And that shifting pattern is repeated. So we can see this C sharp becomes a G sharp. This E sharp becomes a B sharp. This B sharp, which is really a C, becomes a G, E to a B, B to an F sharp, G sharp to a D sharp, A to an E, F sharp to a C sharp. So that should be clear. And like with the numbers, this pattern is repeated on every row, but the only difference is that the transposition does not always stay the same. Ooh. So, for example, this transposition, whilst this one is a fifth, yeah, so the numbers are transposed and they shift, whilst this one is a fifth, the C to the G, the E to the B, this one is a second. Yeah, so A to B, and so on. And what's this one? Well, this is a semitone. So D sharp, which is an E flat, to an E, a B to a C, and so on. So when you are distributing, when you've got your piece of pitch material here, and you're distributing it across the square, you could also sort of randomly choose modulations, or you could come up with a system, or maybe you could have consistent modulations. I want you to experiment with the different things that this throws up. So yeah, what are our pre-compositional decisions when we are distributing pitch? Well, okay, so in the case of Maxwell Davies' Magic Square, the original piece of pitch material that he uses is filled with thirds and fifths. We can see that the C and E, and we have this D, F, A, and the G to B, G sharp to B, well, that's sort of a tritone, but still kind of in the same region. So this is obviously he's picked a piece of material that has certain internal characteristics that when it's modulated, yes, it's modulated and it's shifted, but ultimately this piece of pitch material retains the same sort of internal architecture, this architecture of intervals, similar to the modes of limited transposition that we were looking at. The characteristics of this phrase. So first question in this pre-compositional decision is, what kind of pitch material will you use? How will you consider the characteristics of the pitch material and imagine how it will change and shift and the kinds of patterns that might arise when it is modulated and shifted this way across the square? Second, how will this be replicated across the square? Will you modulate it arbitrarily in a way that's similar to Maxwell Davies? Or will you use a pattern or a system to modulate your material? Will you modulate it to the left, or will you modulate it to the right? And how will that affect it? Lastly, do you even care? Is this square about planning an outcome, considering the material, or is it a process to let things emerge? Either way, you have to commit to the process. So in video 1, I spoke through some context about the piece Ave Maris Stella. By this time you should have looked at the score for the first movement, and you should have listened to the first movement and a few other movements. I've explained what a magic square is. I've explained in the context of traditional magic squares what Peter Maxwell Davies magic square is. I've shown you the process of creating your own magic square and using this magic square as a pre-compositional environment, an environment that has the potential to create different musical lines that will eventually be read to create different musical lines. As I said before, I've shown you how magic square relates to the generation of musical material, and obviously I've shown you how to make your own magic square. In video 2, I'm going to look at how Maxwell Davies reads his magic square, how he extracts material from the magic square in order to create Ave Maristella. I'll talk about the relationship between the broad structure of the piece and the square, and I'm going to show how the magic square manifests as different parts in the first movement of the piece. Thanks for watching, and I'll see you in the next video.